This is Darrell presenting Apple's Develop in Swift Fundamentals curriculum, Unit 2, Lesson 1, Strings. Here we are creating a new string constant. The let keyword means it's a constant. It is named greeting. We use a string literal with quotes to initialize the string, and the compiler can infer that the type is string thanks to the string literal. Other greeting is similar, except it's a variable because we use the var keyword. Here we're creating a multi-line string. We're using 3 quotation marks to start the multi-line string, and then the multi-line string starts on the next line. The multi-line string ends with the 3 quotes, the 3 quotation marks. The indentation in the ending is ignored, so it looks like this is indented 2 characters worth. So the first 2 space characters will not be included in the multi-line string. So this multi-line string has 1 full line, and then a new line, and then another full line, and then it does not have a new line at the end. If you wanted a new line at the end, you'd put another blank line here before your 3 end quotes, or you could do a \n. Strings in Swift are Unicode compliant, which makes it easy to handle emoji and foreign languages and all of your smiling faces and flags and all of the other stuff. So strings in Swift are very powerful because they support Unicode. Because a string literal ends with a quotation mark, it is difficult to include a quotation mark inside a string. In Swift, you use a \/ character to escape certain characters. So you put a \/ before the quotation mark, and as a result, you will have a quotation mark in the string, and that will not that quotation mark will not terminate the string. The \/ will also not be in the string at the end. If you wanted to have a \/ you'd need to put a \/ in front of the \ to escape the \. And you can also put \/ in front of tabs, or \/ in front of R for a carriage return, or in front of an N for a new line. We can initialize an empty string by using 2 quotation marks directly adjacent to each other. This string has no characters, and so if we use the string and we get the .isEmpty computed property, then the computed property would be true. The string is empty. That is different from nil. This string is not nil. It is a string, it's just empty, and it has no characters. In fact, a string cannot be nil. If you wanted a nil string, you would have to have something called an optional string, which is something we will learn about later. A string is composed of characters. Here we initialize a constant a, and we're using a string literal which has only 1 visible letter in it. And a is inferred by the compiler to be a string, even though there is only one character here. If we want, a character is a different type, which can have a character only has 1 character in it. You initialize a character using also a literal, but you have to specify the type as character, because otherwise the compiler would assume that this is of type string. So here A is a string, which is inferred, and B is a character, which is specified by us to the compiler. Swift strings are a collection of characters. So if you have a string with 5, you can have a string with 5 visible characters in it. That string is a collection of 5 characters, and you could iterate through the string and perform an operation on each character. If you want to learn more about how strings are composed, you can go to swiftdoc.org, and you can click on string, and in string you could click on accessing string elements, and it will discuss how a string is a collection of extended grapheme clusters. Each grapheme cluster is 1 visible character. and it might be a simple ASCII character, or it might be a foreign language character, or it might be some sort of emoji, such as in this case we have an example of a flag character. We can concatenate two strings together by adding them. So here we have two string constants, and we use the addition operator on the two strings, and it results in a new string which we put in a variable. Alternatively, we could use the plus equals operator. So in this case, we're taking our variable myString and we're appending another string literal to it, resulting in myString being longer. Adding strings together can be inconvenient, so Swift supports what's called string interpolation. Here we have a print statement with a string literal, and the string literal includes a backslash and then a parenthesis and then a name of another constant, and then the closing parenthesis. In that case, that name is the string Rick. So when we print this out, our output will start with Rick. And you can see this is far more convenient than trying to use a plus statement to add a whole bunch of things together. And in fact, we can put many different data types into this string literal using string interpolation. For example, here age is an integer, which is its value is 30, and the string interpolation automatically converts age into a string and inserts it into our final string. We can include an expression in our string interpolation. Here we're adding the integers a and b, resulting in the integer 9, and then performing the string interpolation on the integer 9, converting it into a string 9, and printing our output. We can test if two strings are the same by using the equals comparison operator. String comparison is case sensitive. So month is equal to other month because every character in month is identical and in the same order as every character in other month. However, lowercase month is different because the first letter is different. A lowercase j is different from an uppercase j. So as a result, month is not equal to lowercase month. If we want to test if two strings are equal ignoring case, then we can use the lowercase method on the string. In this case, the name.lowercase is actually returning a new string, which is Johnny Appleseed, with every character converted to lowercase if necessary. Likewise, we could use the lowercase method on a string literal. In this case, the compiler knows that the string literal Johnny Appleseed is a string, so it will make it a string and execute the lowercase method on it, resulting in Johnny Appleseed lowercase, and then the equal to comparison operator will compare the lowercase name with the lowercase string literal, and in this case that will result in a value of true, and then we will print out the two names are equal. Strings have a has prefix and a has suffix method, so here we have a string constant, and we can test it if the prefix is hello, if the suffix is world lowercase, or if the suffix is world uppercase. In the last case, that would be false. We can use the contains method on a string to see if the string contains a substring, and if it does, it will return true. If it does not, it will return false. We can use the count computed property to determine how many visible characters are in a string. So here we have name, which is a string constant, and then we can use name.count, and that would tell us that name has 10 characters. Here we create a new password, which is 1234, and then if new password.count is less than 8, then this code would be executed. Note that the number of visible characters is different from the size of the string in terms of memory. When we're doing count, we are counting how many characters there are. Because strings are Unicode, a particular character might be 1 byte or it might be multiple bytes, and we can't predict that just by looking at the characters. Swift switch statements are very powerful. We can switch on strings and we can switch on characters. In this case, we are switching on a character to determine if the character is a value. Because there are practically an infinite number of there are an infinite number of possible strings, and there are practically an infinite number of possible characters, and switch statements always have to be exhaustive. Whenever we're switching on a string or switching on a character, we need to have a default case, because it is impossible to enumerate all of the cases. Strings are composed of Unicode characters. Because strings support Unicode, we can include emoji or foreign language characters in our strings without any difficulty. And we can use the .count computed property to print out how many visible characters there are. Again, a reminder, the size of a string in bytes is not equal to the number of characters, because many of these characters require multiple bytes to encode. If you are using the Apple curriculum, go ahead and open up the strings.playground in the lab and open and complete the exercises. Keep in mind that those playgrounds have multiple pages, so don't be fooled by just thinking that there's only one page. This is Apple's slide deck and curriculum, and it is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike 4.0 International License.